All right, guys, welcome back to number 5 and number 6. At some point, I realized that my recording had cut off. So I'm going back a little bit. I don't think this part was on the last video. All right, so what I have right here is secant theta over 1 plus cosine theta equals cosecant squared theta, and then times secant theta minus 1. So generally they say, well, try to work with the side that looks more complicated. Like in this case, this side looked more complicated. And in this case, this side looked more complicated. I think you can see it, yeah. In this case, I mean, they almost look equally complicated, but I'm going to go ahead and work with this side. It looks a little more complicated to me. So the first thing I did was I said, okay, well, cosecant squared. Cosecant squared. So cosecant is the same as 1 over sine. And so I wrote this as 1 over sine squared. And then I just gave this a denominator, right? Put it over 1. Again, only working with this side. So then what I did was I said, well, I'm multiplying here, right? So I'm just going to multiply top to top and bottom to bottom. So I get secant theta minus 1 over sine squared theta. And then what I did here is I said, well, sine squared theta, my goal, remember, is to get cosine in the denominator, 1 plus cosine. And so if I have sine squared theta, I can write that in terms of cosine. And so what I did was I said, okay, well, sine squared theta equals 1 minus cosine squared theta. So I wrote that as 1 minus cosine. All right, and then this is, I think this is where the video cut off. I'm not 100% sure. So where's my blank paper? Oh, there it is. Okay, because I'm going to need some more room. As you can see, I went all the way over to there. And I really don't want to go into number 6, so I'm going to just go on a different sheet of paper. All right, from this point, I'm going to stop writing this left-hand side. Equals, no, I guess I'll write it. It's fine. Secant theta over 1 plus cosine theta equals, okay, now at this point, remember my goal is to get 1 plus cosine, and right now I have 1 minus cosine squared. So what I notice is that this is a difference of squares. It's a squared minus b squared. And off to the side here, I'll just make a note. It's a squared minus b squared, and you'll see this often in proofs. A squared minus b squared always factors as a plus b times a minus b. And so I'm going to rewrite this as 1 plus cosine, 1 minus cosine. So secant theta minus 1 over 1 plus cosine theta, 1 minus cosine theta. All right, excuse me. All right, next. What I really need to do is get this out of the denominator. And so I'm going to see if I can rewrite my numerator in some way. So I know that the relationship between secant and cosine is that they're reciprocal. So I'm going to rewrite secant as 1 over cosine. Now it's going to get a little messy because we're going to have a fraction in the numerator and a denominator already. So we're going to have a fraction within a fraction. Nothing happening on the left-hand side. Remember, we're keeping one side always equal. This becomes 1 over cosine theta. This is still minus 1. And then over 1 plus cosine theta, 1 minus cosine theta. All right, next line. So just so that I don't go off the camera, let me make sure where we're at. Okay, that's good. All right, so my next line, so I've got secant theta over 1 plus cosine theta equals, I'm just going to rewrite this entire thing on this page. So that I can kind of get rid of this paper. All right, so my next step, remember, my goal here is to keep this in my denominator, so it's equal to this. But I want to get rid of this 1 minus cosine theta. And so what I'm going to do is still work in my numerator to try to get this to cancel with something in the numerator. So I'm going to go ahead and get a common denominator in the numerator. So remember, this is over 1. So the denominator that I need, oh, this should be a theta, my bad, is cosine theta. So I'm going to multiply this by cosine theta to both the top and the bottom of this fraction. And so I get secant theta over 1 plus cosine theta equals 1 over cosine theta minus cosine theta over cosine theta, which is still 1. And then that's all over 1 plus cosine theta, 1 minus cosine theta. Now, since they have the same denominator, I'm going to write this as one fraction. So I have secant theta over 1 plus cosine theta equals, this would be 1 minus cosine theta over cosine theta. All right, and this is all over this denominator, 1 plus cosine theta, and then 1 minus cosine theta. All right, so now what I see is I have a 1 minus cosine theta in both the numerator and the denominator. So what I'm going to do is I'm going to multiply both the numerator and denominator by 1 over, let me get my eraser, which is somewhere, hold on. Oh, where did my eraser tape go? There it is. Okay. I'm going to multiply both the numerator and the denominator by 1 minus cosine theta. So 1 over 1 minus cosine theta, I should say. And so what's going to happen is that this will cancel here, and this will cancel here. And so I have secant theta, 1 plus cosine theta, equals, here this whole thing canceled, so I have 1 over cosine theta in the numerator, and then in the denominator I have 1, I don't need the parentheses anymore, so let me drop those, 1 plus cosine theta. So now my denominators match. I just need to make my numerator match, and I know that there's a relationship between secant and 1 over cosine. 1 over cosine is secant, so now I can replace, oh, let me make sure I'm not off the oh, I'm not good. Okay, now I can replace the numerator here. 1 over cosine is, right, the same thing as secant, so I can replace the numerator with secant theta, and I've proven that they're equal. All right, let's go to the next one. Again, I'm probably going to need a lot of extra paper. Okay, so like I said, generally speaking, like the idea is that you want to try to work with the side that looks more complicated. And again, for students in this case, I mean, they almost look equivalently complicated. And so I'm going to go ahead and work with, I think this side to me looks a little more complicated just because of the addition or subtraction. So I'm going to go ahead and work with this side. So I'm not going to do anything to this side. So tangent theta over cosecant theta equals. All right, so I'm going to rewrite secant as 1 over cosine. So this is 1 over cosine theta minus cosine theta over 1. And so now I want to write this in one fraction. So I'm going to get a common denominator. Again, the reason why I know I need a fraction of some kind because I have a fraction over here. So the reason why I chose to rewrite this is it's really the only thing I can do. I could rewrite cosine as well, but I'd rather just try to rewrite secant. All right, so I'm going to multiply this fraction by cosine to both the numerator and the denominator so that I can get a common denominator. So tangent theta over cosecant theta equals 1 over cosine theta minus, this is cosine squared theta over cosine theta. And now that they both have the same denominator, I can write them in one fraction. So I'm going to write this in one fraction. So this is tangent theta over cosecant theta equals 1 minus cosine squared theta over cosine theta. All right, this is sine. Right, 1 minus cosine squared, this is sine squared. I should say not sine, sine squared. So now I have tangent theta over cosecant theta equals sine squared theta over cosine theta. Again, I'll remind you, right, that 1 minus cosine, that's an identity. 1 minus cosine squared is sine squared. All right, so what do I want to do next? Let's see. I think I'm going to split this apart. And the way I'm going to do that is I'm going to rewrite this as sine times sine. So I'm going to have sine theta times sine theta over, I'm going to make one of them be over cosine theta. It doesn't matter which one. If I were to multiply these together, I would still get this back. And the reason I wanted to do that is that if I can get sine over cosine, I'll have tangent. Right? So sine over cosine is tangent. So I have tangent theta over cosecant theta equals this. All right, now I'm going to go ahead and go to another sheet of paper because as you see, I'm out of room. Let me see if I can find my same one so I'm not wasting paper. So let me go ahead and write that last step that I had. So I had tangent theta over cosecant theta equals sine theta over cosine theta times sine theta over 1. Just let me make sure that I'm on the, yes, you can see it just fine. Okay, so now, again, this is tangent, sine over cosine, and I'll just remind you, I keep going back to this paper whenever I get stuck, but sine over cosine is tangent. So tangent theta over cosecant theta, cosecant theta is tangent theta times sine theta. So what I've done is replace sine over cosine with tangent. And then I want to get cosecant in the denominator, and there is a relationship between sine and cosecant. So sine is 1 over cosecant. So this is tangent theta over cosecant theta equals tangent theta times 1 over cosecant theta. If I put that over 1 and I multiply top to top, bottom to bottom, I will have tan theta, cosecant theta, tan theta, cosecant theta. And that's it. All right, guys. So moving on to the next page. Did I already do? Oh, that's the wrong one. I'm sorry. I started to get a little stuck. Okay, so moving on to the next page, which you can see, right, is that we have some homework. It says prove the following. Now, some of these are going to be really easy, and some of them are going to be a little more challenging. Proofs are like that. I don't want you to get bogged down by the proofs. The reason that I say that is proofs are really just about thinking, and sometimes you can't get it, like you just can't get to the end. But you know, you try a few steps and you get stuck somewhere, and as long as that's what you're doing, that's fine, right? I'm going to give you a hint on a couple of these though. So on this one, I might FOIL these, like multiply them together, right? And definitely on this side. On this one, I definitely work on this side, right? There's some stuff that can be rewritten here. This one, I'll just remind you that you can, this is a difference of squares. This is cosine squared x plus sine squared x times cosine squared x minus cosine squared x. And so there's some stuff that you can do there. On this one, I'd probably work on this side. Again, trying to get a common denominator. I'd probably work on this side first, on this guy. And obviously on number 7, on this, I'd have to work on the left side, and on number 1, I'd have to work on the left side. All right, guys, so try the homework, and I will upload this, or sorry, I'll email this to you. If you have questions, please email me back.